Good morning. Okay. Thank you. Good morning, everyone. Let's begin today's journey with an interesting presentation about wax communication, with particular regard to crickets. The students from Ozanam High School, namely Firdaus Asadini, Sumaya Auzi, Eloas Karm, and Amadine Rosana, will be the ones introducing us to this topic.
So, hello everyone. So we are going to present you the cricket communication. So we all have heard the song of crickets on a summer evening, but have we ever thought about how these small animal noises can be very useful to them? In fact, each of their ships, which is the name of the sound made by crickets, allows them to communicate and exchange information. Something like a conversation. That's why we decided to take a closer look at them and to introduce them to you today. So this is a summary. We're going to present the species. After, we are going to talk about their anatomy, their communication, and at the end, the experiments we've done. So, crickets belong to the Orthoptera order and Grylidae family. These small nocturnal insects are closely related to grasshopper and locusts. They are found all over the world, with the exception of polar region, making them cosmopolitan species. There are over 5,000 different species in the world. And some of them produce different songs, which can even allow scientists to recognize the species just by listening to its chirping. Like all insects, crickets have 6 legs. The front legs are more robust to dig burrows and are also equipped with eardrums. And the back legs are adapted to help the cricket jump. Male and female can be easily separated by the ovipositor, which is only found on female and is used to lay eggs. But the part we are more interested in is the elytra, which do not let them fly, but protect them with their resistance, and above all, let the male communicate and produce sounds.
One funny thing about thank you. The chirping of crickets is that this is related to temperature, and by the Dolbear's law, named after the scientists that discovered that, and a lot of species of crickets have more frequency of chirping depending on the temperature, and this is you can find the temperature with the function written here. So it can be slightly different among the species, but I think that's really funny. So.
The crickets don't rub their legs together, but they rub their wings together to make noise. One of the wings is called the scraper, and the other the file. Oh, yeah. The file have jagged teeth, and the scraper rub against the file to make a noise, a chirping noise. And the crickets raise their wings to a 45-degree angle and draw the scraper like this. Oh mon Dieu. So you should like this. Est-ce qu'on voit? Non, il n'y a pas de son. Ok. Ok. Bon. On va essayer. Ouais.
So now I will present you crickets and
So you may wonder how how such a tiny thing can do such a loud noise, and we searched for something to modelize the sound of a cricket and the way they rub their elytras to do this sound. So we found this. This is a South American instrument, and it works exactly the same way as cricket's elytra. So we are gonna like imitate the sound of the crickets. So to the human ear, it can sound similar, but obviously you can't call crickets with that. That just don't work.
okay. So now I will present you crickets communication. So we did. Okay. So crickets communicate with three different chirp. We have the aggressive, the seductive, and the mating chirp. So we decided to do a quick experiment to analyze which chirp is which. So we bought crickets, we raised them, and we separate male and females, and we put male into the female box so that we can analyze and record the different chirps. So here the aggressive chirp, and it doesn't work. Like no, there is no sound. Wait. No, no, wait, sorry, it doesn't work, so I'm just going to show you what we found on the internet about the frequency of each chirp. Put it here. So this is the frequency of the aggressive chirp. We can see that it's very regular and loud. Here is the frequency of the seductive chirp. So the male do these chirps to attract females, to attract females, and it's a very loud chirp. And the mating chirp is way softer, and the goal is to mate with the female and to seduce them. So for the experiments, the first experiment we did is to verify if the frequency were right thanks to the recording that we showed you. I mean, you didn't listen to it, but you understand. So here, the first is the aggressive chirp. You can see that it's quite similar to what we found on the internet, so it's right. The second one is the mating chirp, so it's also quite similar. It's very soft and like not loud. And the third one is the seductive chirp, so it's also very similar to what we found on the web.
Okay, so now I'm gonna introduce the other experiments we made after that. So we put the crickets into different conditions, like one male into the box of the females, or the male together to observe mostly the seductive chirp and the aggressive chirp. So we recorded the sound as Sumaya showed you, and we take videos and observe the way they acted when they were making those sounds. So here's the first video. So we see only male here, and as you can observe, there's a form of aggressivity from the cricket here. So only the males chirps. So you can see there the male acting aggressive towards the other cricket and defending his territory, and associated with the aggressive chirp you showed you earlier. The third experiment is so the male in the box of all the females, and the seductive chirp by the male. So we don't see the cricket chirp here, but he just did, and we see him there, and as you can see, all the female with the ovipositor here are around the male and are like presenting to wait for like the mating. So this is a way for the male to attract the female. The last experiment was an experiment with the females to see if they are really attracted to the sound of the seductive chirp. So we did controlled trials and then tests. The controlled trials, so we built a maze, like a maze in cardboard with a glass here to see into the maze. We recorded every path the crickets would start here to draw the path later. And the chirp was coming from here. This is all the same maze. So we started with a female cricket doing the maze without any chirp, and well, she's doing nothing in particular. She's just while walking. So yes, obviously, and we try this with the deformal. Well, the ears of the crickets are on the forearms, the equivalent of the forearms. So this one had already like one missing leg and the other really not well. So she couldn't hear anything, and like she obviously couldn't hear the sound, so that was part of our control trials. The test for the test we take we took a normal cricket, normal female cricket, and we put chirp here. And as you can see, 2 times the crickets find a way to join the origin of the shrub, and in 2 other tests, they didn't really found the sound, but it works well. It works 2 times, but 2 other times either she wasn't in condition, or either she just didn't found the origin of the shrub. Either way, she wasn't interested, apparently. So we can't really conclude anything on that. We can't really say that here the female cricket was able to do the maze, to find the origin of the shrub, but we can see that sometimes they're searching for it. So, well, this is the conclusion of our experiment.
So to sum up, crickets are an interesting model in terms of communication, thanks to their complex chirping. After looking at an example of sound communication, we must not forget that insect communication is vast and diverse. Indeed, it is just as interesting to look at other forms of communication. Just to give a few examples, many animals, like ants, use pheromones or other chemical substances to transmit information. Some animals also use visual communication with gesture, such as bees that dance to show direction, or butterflies that use the color of their wings to show their toxicity. Insects also use tactile communication, as the beetle does to warn of danger. So each of these examples illustrates how insects have developed a variety of communication strategies adapted to their specific needs. So that's the end of the presentation. So thank you everyone for listening to us.
Okay, so we are moving on to our next project, which is communication between animal and the human. Let me call on the stage the presenters, Odile Guise, Nero Ecke from Institut de la Providence de Champion.
You can select yours from the list. And here's the presenter. You can use this too. Yeah, it's where? With this back, this forward. Yeah.
And that's it, okay.
Je stresse. Vous n'êtes pas obligé de nous filmer par contre. Vous n'êtes pas obligé de filmer tout ça. Oui, un petit peu, mais pas tout ça. Oh, thank you.
Always at work. Comment est-ce qu'on présente?
C'est toi qui commence en fait. J'ai peur. Ça me stresse, mais non. J'étais dans le début, il y a 5 minutes.
Ça, là?
Ah oui, ok. Ah, on voit après, c'est génial. Non, non, mais il y en a un qui pousse, qui passe à côté. Mais t'as un micro, en fait, je stressais pas avant et c'est maintenant que je stresse. Tiens, c'est toi qui commence. Mais arrête de faire ça là.
Ok, c'est bon. So, I have never spoken in a microphone before, so is everybody okay? Okay, that's fine. Low, low. Nice. So, hi everybody. Today we are going to present you communication with whales. So it's our topic after the cricket. But before, let us introduce ourselves. My name is Nero Ecke. I'm 16 years old. I'm from Institut de la Providence de Champion in French. And she is Odile Guige, and she's also my classmate. And she's also 16 years old. So, our topic now is about communication with whales. You already know it. And we are going to present you a few points about what is first communication with animals, because it was the first topic. And then we had to choose a species, because of course speaking about each animal, you know, it's a bit long. So we picked up the whales because it's the most understood species for our current scientists. So here is the table of contents. We are first going to speak about the reason to communicate with whales, then how do the whale communicate, how do the remit lessons, how to communicate with them, what has already been done, and of course, a point that's I think very important, is it ethically allowed to communicate with animals, because it's a bit strange and is, I like said, allowed to pass through species barriers, because are we really allowed to do this? So, first, why do we want to communicate with whales? Wait a minute. Yeah. So, the reason to communicate with whales are first that it's difficult for us to communicate with them because passing through species barrier, as I said before, is very different because we have to pass through language, we have to pass through the ways of thinking, because you know that us in this room, we have some different languages. Okay, we can speak in English, obviously, but of course we have also some different way of thinking. I mean, I have some habits, you have some habits, and we are not used with it. So imagine with animals, how is it different? Then, of course, to understand them, we have to understand the motivations. What could they talk about? I will use the term talks because it's kind of like this. And how does it work? And then we can maybe understand it and make us understood by them. So Then, so, how do they communicate?
So how do the whales communicate? They produce sounds in underwater between 5 and 200,000 hertz. It's very big number because a human, just you can see the difference, can hear between 20 and 20,000 hertz. So you can see on the picture that human is a very low, large hearing range, and whales it's like the dolphin. So you can see, and the sounds can go like more than 100 kilometers underwater. So it's very far, and they can transmit very important information like the presence of food or the dangerous thing like boat or predator.
So, that was about how do they communicate, but now the question is how do they make all of those sounds? So, not there. So, to communicate, they use the larynx. Larynx, yeah. So, here is a picture that you can maybe understand better. So, an experience made by Cohen-Selmans and his team, so he was the leader, made an experience on 3 different larynxes of whales, different species of whales, kind of whales, and he discovered that actually when the lunch is full of hair, the whale push it through the larynx, so we can see the larynx there, of course the lunch here. And in the larynx, there are some cartilaginous cords. It's a bit like our vocal cords. Mine are a bit destroyed, but and there it vibrates a lot. And by vibrating, it makes, of course, sounds. They also have like a pocket under it to make it more not strong, but I think you understand me. So the conclusion is that to produce these songs by pushing air through the larynxes. So yeah. Your point.
Okay, so to communicate, so to try to communicate with whales, we can use 2 main ways. So the first one is to record the sounds and analyze them and try to know what it means, but it's very complicated, and try to compose sentence with that. So you can see that the CETI team do like a thing who they choose like for different screen, different symbol, and try to make a sentence, but we don't know what does it mean. And yeah, so and then we want to create a song to listen the ways and see what their reaction.
So that was the first way to try to do it, and my classmates just got one thing. Like the city team, we will speak about this later, but it's a team of scientists who are working on it. So the second way to do it is maybe not more interesting, but it's better, because we can maybe go further with it. So the idea is, like you see, to use the AI to analyze the sounds of the whale, and with them we can maybe understand how it works, and by understand this we can maybe make a system to communicate. Okay, so that's the idea. There is already some AI called LLM for large system machine about languages. So the goal of this AI is to understand a language, then put it on a system and use it again. So that's actually maybe the best AI we can use. And we talk about this AI because that's what they did with this AI. So the goal is not to copy their sounds, but to recreate sounds with what we understood. So that's maybe better if we want to communicate. But of course, we have to understand that they don't speak like us, so they have some different way, different thing to say, and we first have to understand it, like I said before. So the question now is, what has already been done with those AI and everything?
So we are going to talk about two experiments that has already been done. So the first one is a scientist. It's Michel Fournet. It's a teacher of marine biology at Hampshire University, and she analyzed some records of sounds of whales to try to understand them. And she noticed that every whale do very often a song, and she tried to find a meaning, and she found that it was I'm here. So she tried to understand it, and it was the signification she found. So she wanted to try in real condition. So she went to Alaska and put the sound in the water, and some whales came to the sources. So, yeah.
So that was the first experiment. But in this experiment, the first one, so with Michel Fournet, it wasn't really with the AI. She did it by herself. It took, like my classmate said, 10 years, so pretty long. But another teams of scientists called SETI, as I said before, tried to make the same thing but with AI. And so they recorded a song of whales, a family of whales in Alaska too, and then they tried to analyze it with the AI. And they understood that, like Michel Fournet used it, there is like a contact call. It's like, I'm here, okay? And of course, they went trying it in Alaska, and actually it works. It was a few months ago, so it's pretty recent. And what's happened then is that a whale, they're called the whale Twain, is it a real picture of the whale, came to the boat and start to turn around the boat for something like 20 minutes, so it's kind of long. And what's happened is that they're not communicate with the whale because they didn't know what they were saying, but they start to share with the whale. Why? Because when they emit sounds, they wait a few minutes or a few seconds, and the whale after make the same song but wait the same time. So it was actually a bit strange. It was the first step. So yeah, actually it's not really like communication like hello, good morning, how are you, but it's like a sharing with animals, and that's already something. It's a whale, not a dog or a cat, but a whale. It's something I think kind of impressive. So now the question I asked before, is it ethically allowed?
So is it ethically allowed to try to understand animals? Because are we really do we really need to understand what they say? Because all the species are their own language, and we don't know if we have to understand them, because the humans are a danger for a lot of animals. So if we understand them, it's a little bit strange. So we all have our own way to communicate, and it's maybe most dangerous for them to be understood by humans. And it's like you pick a word in a dictionary in another in another language, and you say it to a guy who speaks that language, and you don't know what does it mean. So why we have to do that? It's a little bit strange, but maybe there are good points. But everyone has different opinion. Okay, so in conclusion, we can talk about 4 points. Like the scientists do a lot of discovery every day, but it's not for tomorrow that we'll understand animals. but one day we could probably exchange information with them, and but not today. And it's probably with AI that we'll be able to do it. And maybe we don't have to understand them because it's the law of the nature, but everybody can have their own opinion. So thank you for your listening, and I hope you liked our presentation.
Thank you.
Okay, the next presentation will explore the role of human-animal bonds in the communication between them. Please welcome to the stage Kato de Groot and Biray Karaka from Het Stedelijk Lyceum Cotton Park.
Excuse me, does someone know which one we should click? Okay. Oh.
Hoe moet je klikken? Hier?
Yeah. Okay.
So, hi everyone. Welcome to our presentation. My name is Barry Karaja.
And my name is Kato.
And today we will be talking about the communication between humans and animals. So, we will be talking about why we chose this topic, the experiment, research question, hypothesis, results, conclusion, and finally the discussion. So why did we actually choose this experiment? So when we first heard that we had to talk about communication, we had absolutely no idea what we wanted to talk about. But Kato wanted to include animals, so we thought maybe we're going to go in that direction. And then I added some things, and after some brainstorming, we decided on, this experiment.
So what we did was we looked around and we found people that owned dogs. Then we asked them if we could execute some tests on their dogs. That sounds really sketchy, but all we did was ask the dog to come over, sit down, and give us a paw. Then we recorded the time that it took the dog to perform these actions and wrote that down. And then we had the owner of the dog ask the dog the same questions and see if there was a difference in response time with the owner versus with a stranger. We also took in other observations, like whether the command had to be repeated, or if it was an old dog, obviously it might have been like a slower reaction time than with a young dog, or maybe a puppy is not as good at concentrating as an older dog.
Yeah, all in all, our research question became, do dogs communicate more effectively with their owner than with a stranger?
So our hypothesis is as follows. Over time, dogs form a bond with their owners because they spend a lot of time with them, they communicate, they interact, and they get a lot of shared experience eventually. In this process, they all get used to each other, and because of this, we hypothesize that dogs will communicate better with their owner because they know their owner. So firstly, we interviewed, I guess, this 3-year-old French bulldog named Cody, and as you can see in the results, he was a bit quicker with his owner, except for when we asked him to come over. He came to me quicker than he did to the woman that he lives with. Next we have Sam. Sam is a Labrador and he's older. He had quicker results with his owner than he did with me. Especially when I called him to come to me, it took a long time, and I had to repeat the command often. He didn't really want to come. And next we have Elsie, also a Labrador. She's 10 years old, which is also on the older side. And when I called her over to me, she did not come at all. She just stayed there. She wouldn't even get up. She looked at me like, why are you even doing this? Overall, she was faster with all the commands with her owner.
Yeah, so here we have Sep, a 3-year-old Seskifusek, and he's pretty young. And as you can see here, with Come Over Here and Paw, he took longer with the owner, and with Sit, he took longer with me. That was also partly my fault, because I had to do a hand movement, which I did not do at first. So the hand movement was really crucial, and so we see that nonverbal communication is also very important. Here we have Bella, a 2-year-old, so still young, Norwich Terrier. And with Come Over Here, she also took her time with the owner. And yeah, with the other tests, she succeeded. And the owner had to repeat quite a few times. And now we have Gizmo, so a slightly older dog. A 7-year-old poodle mix, and with all the tests he came faster to the owner rather than the stranger. And the stranger obviously had to repeat the commands pretty often.
All right, so in general, our results state that the dogs responded faster to their owners and sometimes even more energetically. Like, for example, the dog would run to their owner when called, and when a stranger called them, they would just slowly walk. Like, do I have to go here? Okay. It was often about a 2-second difference in response time with the sitting down and the paw command. And this agrees with our hypothesis and tells us all that dogs communicate better, maybe quicker is a better word, with someone they know. What was interesting is that many dogs with the call command responded quicker when a stranger called them compared to their owner, which is weird because you think they would want to see their owner more than a stranger, but it could also mean that tells something about their personality, maybe they really like other people. Then we had 2 Labrador dogs in the experiment of about the same age, and both of these dogs didn't want to come up to the stranger. So maybe that says something about the breed, or it could also just be the personality.
So now we're at the discussion, but overall the experiment went pretty well. We would actually like to do things a bit different next time. And that would be like, we obviously included the age and the breed, but we didn't have, like, all the dogs were different, so maybe it would have been better if we would just exclude the age and the breed. But it's very hard to find all the dogs that are the same age and the same breed. And yeah, we only had 6 dogs, which is not reliable at all. We need, I think, like a couple of hundred more to actually like show the actual results. Yeah, we wanted to do the research online. We couldn't find any results whatsoever, so that was pretty sad. And as you had seen, like, we first asked the owner to ask the test and then ourselves. And maybe if we switched up the order, the results would have been different. So that's pretty much it.
Yeah, I also wanted to say something about how what we didn't realize at first, but we found out when we started visiting these places and talking to these people, that many people train their dogs with visual aids. Like for sit down, they would have like something like this, which is also really interesting to look at, to see how visual aids impact the communicating and not just the verbal aids.
Thanks
for listening.
Okay, so let's continue with the obesity, an issue undeniably important to discuss. The presentation will be held in 3 main parts by students of Eötvös József Secondary School named Adrian Todd, Leah Rose Stacy, Rebecca Máté Sáfár, Olivia Haluska, Blanka Megadja, and Nimrod Zalán Simon.
So our presentation is about the science of obesity. And we'd like to give a bit of background information as to why we chose this theme for our project. And the overarching theme for YRoNS 2024 is communication. And our body's communication with us is one of the most important forms of communication there is. And we would like to, wanted to delve into this slightly more. Our method of research was a questionnaire which covered 3 important aspects of this, 3 important facets of this theme, which is obesity the epidemic of our time? How has it changed and is changing in the 20th and 21st centuries? And the measurement of obesity and its consumer price. For our questionnaire, we administered this to 107 individuals through different age groups as well.
The initial idea of the research was to examine the ideal body shapes throughout the history before Christ until the 19th century. In ancient Greece, it was discovered that obesity was a disorder. As Hippocrates, the father of medicine, said, being fat is not simply a disease, but a precursor to other diseases. And in the Renaissance era, being overweight was a commonplace. It was actually a symbol of wealth, within which it meant good ways. At the beginning of the Industrial Revolution, we realized that our body size has a huge influence on our weight, including that strength is not in fat people. And as we can see, it is a social problem. Discrimination against obesity basically affects women. It is not expected of men.
Okay, so our next question is, why are obesity rates rising worldwide? Now, it's quite an interesting question and a quite hard one. Why are they? Why is there an insane increase of numbers each day? The numbers are going up each day. Now, it is hard to answer, and there's many causes of it. So I thought I'll just bring a bit easier answer, question, which doesn't answer it fully, but it goes into quite a deep point of it. What do you see when you walk into a supermarket? What surrounds you? What do you end up putting into your basket? Think about it. What do you end up paying for, buying, consuming? 90% of the goods that exist today did not exist 100 years ago. The same way how 90% of the health problems that exist today did not exist 100 years ago. So that is insane if you try to think about it, how there's a huge connection and how humanity kind of ignores the fact there could be a connection. We just go on, close our eyes and not even notice it. We are buying our own way into health problems. Humanity is digging its own grave. And when I say it's digging its own grave, I'm not saying that tomorrow we'll all get up dead. In that case, we wouldn't get up. All I'm saying is that 1 in 8 adults in the world is obese, and that adds up to an incredible number. It's an incredible amount of people suffering. Some countries are dealing with childhood obesity. And if I just say childhood obesity, it doesn't mean much, but if you think about it, there are kids below 9 years old already increasing their chances of an early death, suffering. So when I say we're digging our own hole, all I mean is we are the ones making the huge variety of we shouldn't just have a jelly bean, but let's have a Coca-Cola tasting jelly bean, or we're the ones producing it, we're the ones selling it, and then we're the ones paying for it, buying it, consuming it. In the end, we're the ones suffering, having to endure its causes. And it's our health system being overburdened, trying to help us, cure us. So all I'm asking for, let's try to open our eyes and see there could be a connection between the two.
Furthermore, the body positivity movement, while aiming to promote acceptance of diverse body types, has its disadvantages. One significant drawback is the normalization of unhealthy behaviors such as overeating or sedentary lifestyles, under the guise of body acceptance. This can inadvertently convince individuals that they are healthy when they are not, potentially leading to serious health consequences. Tragically, some even have lost their lives due to perpetuating unhealthy habits in the name of body positivity. Thus, while fostering self-love and acceptance is important, it's crucial to maintain awareness of health implications and promote balanced well-being.
So I tested for fats in coconut and olive oil to see what actually goes in our bodies when we consume fatty foods. So Sudan-3 dyes fats because it's also non-polar, so it's a fat-soluble red dye. And I modeled the action of bile salts in digestion, which is emulsification, by adding dishwashing soap, which also has an emulsifying effect. So, like, as you can see, if I shake it a bit up, it emulsifies the fats, and you can also see this here. Yeah. So this is like a few images of how it actually works. Like the hydrophilic side is outside of the fat molecule. Oh. Yeah. So, and the hydrophobic side is in, and it breaks down. So the enzyme, which actually consumes and digests the fats, can have better access to it, thus it's more effective. And you can see the process here.
So, our hypothesis is that people who exercise frequently are thinner and have less body mass and a lower body fat percentage. We tell that because when people exercise, they use energy, which comes from supplementary nutrients. So less supplementary nutrients equals less weight. We used the body mass index to calculate. To do this, we needed the height and the weight of the people.
The first question was, which shape you like better? And based on the answers of today's generation, the thinner body is the more ideal and the most beautiful, and you can see that on the first diagram. And the second question concerned the case of women. Why is obesity of women only a social issue? And according to our age group, patriarchal society is the main one, where men control and decide. Due to this, more men are attracted to thinner women. And you can see that on the second diagram.
Our next question was what our students answered, or the question takers, is why is the number of obese people increasing worldwide? Now, as you can see, most people answered with the world is starting to normalize an unhealthy lifestyle. And I think that kind of is the point. But a bit more interesting question, is obesity a disease? There are still scientists having discussions about it. There isn't a given answer yet. At the moment, it's said to be a disease because there are preventions you can take and there are causes of it. Even though, as most people think, as in our question takers also thought that it's not a disease because they can't help. It's not a disease, but it leads to many diseases. Now that's very true, but it is, at the moment, it is said to be a disease because there are preventions and causes of it.
This diagram shows the relation between weight and height of the people. We can see a trend according which the taller person is, the greater their body mass. We categorize the people by their BMI. We can see that the 60% of them have an ideal BMI, the 38% of them are thin, and only 2% of them are overweight. But what does it mean? It means that we can't draw any conclusions because regarding the overweight people, as they make up only 2% of the test takers. Now we know that the hypothesis is wrong. We concluded that because the people who exercise actually lose weight, but then they build muscles, which is heavier than fat. And thank you for your attention.
The aim of the next presentation, held by Lena Barton, Jule Linden, and Mona Leyendecker from Nikolaus von Kues Gymnasium, will be to encourage us, the audience, to move our bodies. Let's get right to it.
Wollt ihr an der Tafel stehen? Das geht nicht auf.
Oh, my muscles are too weak. Mine too. I don't want to sweat anymore. What about artificial muscles? I have an idea. To the left. Let's experiment.
Hello, welcome, bonjour. I'm Mona.
I'm Jule. And my name is Lena.
And we're from the Nikolaus von Kues Gymnasium in Germany. And today we will present you our team, Move Your Body, synthetic muscles made of polymers make it possible.
So to give you a short introduction into our topic, I would like to start with the question, why do we need our muscles? Therefore, we'll first of all look at the structure of our muscles. So our muscle consists of strands, and each strand consists of sarcomeres. These sarcomeres contain contraction proteins called myosin and actin. The chemical interaction between these two proteins are responsible for our muscles to contract, relax, and produce force. So the main functions of our muscles are movement, posture, joint stability, and also heat production. But you might want to know what this all has to do with the topic of the YRoNS Conference 2024 communication. Therefore, I have a simple answer: muscle communication. Our muscles have the ability to communicate with each other and the nervous system to enable movement. This communication occurs through electrical signals exchanged between nerve cells and muscle fibers. The center of our communication is our brain.
Yeah, as Jule just explained, the human muscle system is very complex. To create a very similar artificial system, materials that are soft as well as controllable are needed. To use electroactive polymers is a solution for these conditions. By applying small electric voltages, they can change their shape and exert a strong force. The use of electroactive polymers have many advantages. For example, they have good power transmission and functionality in the air. They have an integrated sensor functionality and are absolutely quiet. Additionally, they are comparatively easy to produce. So in general, they can be used very well to synthetically imitate biological deformation principles.
So, for our first experiment, we wanted to create a synthetic muscle out of pyrrole. In the left, you can see our materials out of which we wanted to create this muscle. Yeah, so first we had to produce our stripe. For this, we cleaned a piece of graphite foil using acetone. And after this, we covered the piece of graphite foil with a stripe of Tesafilm, and we used something to straighten it. We used a ruler, which you can see here. And after we ripped off our stripe of Tesafilm, we had our final stripe, which can directly be used in our next step. And in our second step, we had to create an electrolyte solution. For this, we used lithium perchlorate, sodium dodecylbenzoyl sulfonate, pyrrole, and this mixture was filled up with distilled water until it reached 100 milliliters. And this mixture was put on a magnetic stirrer and then mixed until we had our finally dissolved electrolyte solution. And in our next step, we built an electric circuit, which you can see here. And for this, we filled our electrolyte solution in a transparent box. And then our Tesafilm stripe is switched as a negative pole and a piece of graphite foil as a positive pole. And then we had to wait 30 to 45 minutes until we saw our results.
Yeah, and this was our result. With the passage of time, a black crumbly plastic has settled on a Tesafilm stripe. Here in this picture, you can see the part of the Tesafilm stripe that was outside the electrolyte solution. And as you can see, there is a big difference between this part and the part that was inside the solution. It's black and no longer gray like the graphite rests here. So this is our polypyrrole. But how does this work? This is the chemical structure of a pyrrole molecule, and that's the chemical structure of a polypyrrole molecule. But how does it bind from a monomer to a polymer? Here we have a mechanism for you, which I will explain to you now. So at first, the first step is the formation of the radical cation. So an electron is split off of the pyrrole molecule. As a consequence, we don't have two double bindings anymore, but one, and one carbon atom with a free electron, and another one with a positive formal charging. In the second step, there's a condensation of two radical cations. So we now have two of these radical cations, and they connect, while two protons are split off. And as a consequence, we have a dimer without any formal chargings. In the third step, this dimer is then oxidized by another radical cation, so it hands over an electron to the radical cation, which is now happy without any formal chargings. And the dimer is again a radical cation with a carbon atom with a free electron and another carbon atom with a positive formal charging. And the fourth step is just the propagation of the chain reaction. So this dimer, it connects again to a radical cation, while two protons are split off, just like in step 2. And then this molecule is again oxidized by a radical cation, and then it connects again to a radical cation. So this process, it continues, it just goes on and on and on until we have this huge polypyrrole molecule.
So after Lena explained to you the mechanism, I want to give you a short explanation of the storage of anions in the polymer matrix. So in our cell, the graphite electrode functions as a plus pole, having an electron deficiency. The polypyrrole emits electrons and hereby serves as the anode. While being oxidized in the process, as Lena explained to you, we have a positive charge in the polypyrrole. To balance it, ClO4- and DBS ions are stored in the polymer. Both the equation and the mechanism show how the balancing and the work.
So, secondly, we have a second experiment for you. This time we wanted to show the possible movement of the synthetic muscle we created. And for this we had to again produce an electrolyte solution, but this time only with lithium perchlorate and distilled water. And this would put on a magnetic stirrer and mixed until we had our dissolved electrolyte solution. And then we had to again build an electric circuit. This time we cut our polypyrrole stripe, which you can see in this picture, into a small stripe. We did this with the help of a knife and a ruler. And in the second step, the polypyrrole stripe is then switched as a negative pole, and a piece of graphite foil, which we also cleaned with acetone, is switched as a positive pole. And you are able to see the electric circuit in the third picture, where this is our negative pole and this is our positive pole. But what happens now? As you are able to see in this video we took, our polypyrrole stripe is slowly moving away from the graphite foil. You can see it here. It curls in, as you will see. It's like not very slow, it goes very fast. So you can think of a result. When we switch the polypyrrole stripe as a minus pole in the second picture, you saw in our video that it is moving away from the graphite foil like this. And when we then switch the polarity, so the stripe of polypyrrole is switched as a plus pole and a piece of graphite foil as a minus pole, it causes the stripe to unroll again into a straight line. And you can clearly see that it's moving towards the graphite foil, so it shows the movement of the muscle.
Okay, but how is our muscle able to move? In the beginning, polypyrrole is switched as a minus pole, so it has a cathodic load. As a consequence, it is being reduced, which means it picks up electrons. To compensate the charge, lithium plus ions have to be stored, and perchlorate anions have to be outsourced. Here, in this picture, you can see that because of the storage of the lithium plus ions, the muscle is stretched, which leads to an extension of the muscle. The explanation for the anodic load of polypyrrole is very similar to the one before. So as a consequence of polypyrrole being switched as the plus pole, it is oxidized, which means that electrons are being dispensed. This time, the lithium plus ions have to be outsourced to compensate the charge. And here in this picture, you can see that because of the outsourcing, the muscle moves first again into a straight line, and then it contracts.
So in our second experiment, we tested if our handmade muscle could really move. And now in our third experiment, we wanted to check if it is able to lift weights. Therefore, we again created electrolyte solution with lithium perchlorate and distilled water and put it on a magnetic stirrer to mix everything up together. After that, our second step was to create a dumbbell. For that, we cut the polypyrrole stripe into small stripes, then cut a pin of a pinboard off and melted it back in the middle. And this is then attached to the polypyrrole stripe, as you can see here in this picture, and we had our muscle with its small dumbbell. Then we again built an electric circuit with the polypyrrole stripe as the negative pole and a piece of graphite foil as the positive pole. But what happens now?
So in our second video, you will be able to see that our polypyrrole stripe with the little dumbbell we created ourselves is slowly moving towards the graphite foil. It's not as fast as our first one, like you saw in our video before, but it's curling in. So our result of the third experiment was when the polypyrrole strap is switched as a plus pole, which you can see here. It curls towards the graphite foil, as you saw in our video. And when we then reverse the polarity, so our polypyrrole stripe is now switched as a minus pole, and a piece of graphite foil is switched as a positive pole, it causes our polypyrrole stripe to unroll again into a straight line, and this time you can also clearly see that it's moving away from the graphite foil, so you can clearly see the movement. And because of this experiment, we are now able to say that our muscle is able to lift the weight we created. But you maybe think, how strong is our muscle really? We have an example for you. We can say that our synthetic muscle is able to lift 10 times its own weight. So now you could say Lena can lift 600 kilos.
Okay, finally we want to present to you an outlook of the research of polypyrrole as a synthetic muscle. Artificial muscles have a huge area of application. They can be used in prosthetics, robotics, medicine, and also aviation and space travel. A few examples of the use of electroactive polymers are to use them as realistic replacement limbs, power-enhancing exoskeletons, humanoid robots, and there's also a current research going on how to use polypyrrole to help people with Alzheimer's disease. So, but all these researches are a lot of work because it's very challenging to combine the whole potential of artificial muscles in a single universally applicable product. Moreover, it is quite difficult to realize the communication from the brain to the muscles.
So now we want to thank you for your attention, and we hope you liked our presentation and learned something out of it.
Okay, so now we'll hold a short 15-minute break. Please be back at 9:15 so we can continue with our presentations.
and about cells.
Dear organizers, dear mentor teachers, young researchers, I am very grateful that I have the opportunity to present here. Has it ever occurred to you that our blood vessels contain our blood perfectly at high pressures without ever any leakage occurring in our blood vessels? Yet, some cells can pass through our blood vessels without a single drop of blood leaking out. Now, this process is called transmigration, and we have two vital examples for it in our bodies. The first one is our body's main line of defense, which is our immune system. As you know, white blood cells need to pass through the vessel wall in order to fight pathogens. I could say this is a question of life or death for us, if transmigration works for the white blood cells. Secondly, tumor cells also need to pass through our blood vessels in order to form secondary cancer tumors. I could say this is also a question of life or death, if transmigration works here. So we can see that transmigration is an absolutely vital process in our bodies, and it is very important for several reasons. Yet, many of its details are still unknown to us. This is the reason why we have chosen to uncover the secrets of the transmigration process. But why is transmigration actually important to know more about? Well, any information that we gain on transmigration will move us closer to developing drugs that can prevent the formation of cancer metastasis. Let's just imagine that we find the mechanism in transmigration, maybe a single protein that we can block that makes the transmigration of cancer cells through the vessel wall harder. Then we have opened the door towards research in drugs that can prevent metastasis. So we can see that this topic is vitally important. In order to understand our experiments, we need to first understand the process of transmigration. Here, I am using a leukocyte, a white blood cell, to illustrate the whole process, but the process is very similar with cancer cells. So everything that I say about the transmigration of white blood cells applies to cancer cell transmigration as well. So yes, and also the inner wall, that is a one-layered epithelial wall in the inside of the vessel, is called endothelia. That is how I will reference it mostly. So how transmigration works is that leukocytes are floating in our bloodstream and they collide with the vessel wall many times. However, when they detect the right signaling molecules on the vessel wall, then they stick to the vessel wall and start rolling. This is the capture and rolling step. Then the adhesion between the leukocyte and the vessel wall strengthens, and the white blood cell flattens on the surface of the endothelia. This is the second step. And then the leukocyte applies pressure to the endothelial wall, and it opens up cell junctions, and then it squeezes itself through the vessel wall. Now, some researchers have observed that in the adhesion step, small docking structures form on the surface of the endothelia. We call them philopodia, and they seem to help the white blood cells and other cells in the transmigration process. However, we know very little about them. We could say that they are one of the most mystical main characters of the whole transmigration process. So that is why we have chosen to focus on the philopodia in our experiments specifically. However, these philopodia are very small. They are less than a micron in their size. So it is a very hard job to find them. And for that reason, we have used 3 proteins that can give us clues on how to hunt down Filopodia and how to actually analyze them. So we have a few proteins that can guide us to Filopodia. These are our clues in the experiment. The first protein is the protein called ICAM1, which is a membrane protein that can be found on the membrane of the endothelial cells. And some researchers have observed that the surface of the Filopodia is densely coated with this ICAM1 membrane protein. The second clue that we have is the myosin 10 protein, which was also observed by some researchers to be found in the Filopodia. And our third clue is that we also know that actin filaments stretch across the Filopodia. So we have these 3 clues that we know are proteins that can be found in Filopodia, and as good detectives, we will be looking for the simultaneous presence of all of these or several of these 3 proteins. However, we also need some bait in order to lure out Filopodia and to be able to catch them. And the first of these 2 baits is the complementar protein of ICAM1. Now, this protein is normally found on the membrane of the leukocytes. It is a membrane protein, and its job is to bind together with the ICAM1 membrane protein, and this is actually the main mechanism behind the adhesion of the leukocyte in the transmigration process. So these 2 membrane proteins can bind together in order for the leukocytes to adhere. So this is one of the baits that we will use. The second bait is what I told you about, that the leukocyte exerts force on the endothelial wall in order to open the cell junctions and to squeeze itself through. This force was measured by some scientists to be around 5 to 50 piconewtons, and we will also use this force in order to trick the endothelial cells into thinking that a leukocyte is trying to transmigrate. So our main goal is to, as I said, trick the endothelial cells into thinking that a leukocyte wants to pass through the cell wall. We will do this by designing an experiment that uses a model system. In this model system, the white blood cell will be modeled with a small magnetic bead that is covered with anti-ICAM1 proteins. These anti-ICAM1 proteins are actually antigens, but they are, in this experiment, very similar to the ICAM1 complementar proteins that I have told you about. They have the same function. They can bind to the ICAM1 proteins on the surface of the endothelial cell. So basically, this magnetic bead coated with the anti-ICAM1 proteins is our fake white blood cell. We are using this to model the leukocyte. And you will learn just in a second why it is magnetic. To model the endothelial wall, we have used human endothelial cells, and we have plotted them in a 1-layer cell culture in petri dishes, in actually several petri dishes, and this is our model of the endothelial wall. And we have designed 3 experimental conditions. The first one is the control condition, where we've just plotted the endothelial cells in the petri dish, and we didn't perform any further actions on them. The second condition is the adhesion petri dish, where we added these fake leukocytes to the cell layer, and then we analyzed the results. And the third condition, which is the most interesting one, is where we added the magnetic beads to the cell layer, and then we placed a magnet on top of the petri dish. And the magnet exerted force, it attracted our magnetic beads. So the magnetic beads exerted force on the endothelial cell layer just as a white blood cell would have exerted force. So in this experiment, we are modeling the adhesion of the leukocyte membrane proteins with the anti-ICAM1 proteins, and we are modeling the force exerted by the leukocyte by attracting these magnetic beads in this experimental condition with a magnet. So we have tricked the cells, we have performed our experiment. However, we need to make our filopodia visible, so here is where we will use our protein clues that I told you about in the beginning. First, we fixed these cells with formaldehyde, that is a simple preserving step, and then we have used a immunofluorescence staining technique in 2 steps in order to mark the 3 proteins, ICAM1, myosin 10, and actin, to be visible. In this immunofluorescence staining, we used 3 different antibodies that are protein-specific. One binds to actin, one binds to ICAM1, and one binds to myosin 10. And these antibodies also had different fluorescent parts that had different excitation wavelength. So we could detect the 3 different proteins separately. So with this staining technique, we were able to mark the 3 proteins with a different fluorescent part by using antibodies. And then we used a fluorescent confocal microscope to analyze our samples. Now this microscope had 3 lasers that corresponded to the excitation wavelength of the fluorescent part on the different antibodies. So we were able to detect the different protein layouts with the microscope separately. And our microscope had one more trick, which is that it was a confocal microscope. That simply means that it can focus at different depths in the sample and create recordings at different depths as if we were optically slicing up the sample. So we made different pictures at different depths. That made it possible for us to analyze our samples in 3 dimensions instead of a simple 2-dimensional picture. So I bet you are all very excited now to see if we've actually cached some filopodia. So here first I'm showing you some layouts of the ICAM1 proteins that we have recorded in the microscope. Now firstly, can someone tell me what can this small circular thing be on the adhesion sample? Do you have any guess for what this is? It's actually the magnetic bead that we have added to the adhesion sample under the microscope. So this is how they look like. Now the first interesting thing that we can observe in the adhesion sample is that small ICAM1 clusters form on the top of the cells. And the ICAM also seems to be more dense in cell junctions compared to the control. Now, what is even more interesting is that, contrary to our expectations, the ICAM1 clusters almost completely disappear on the sample that was also subjected to force. So here we are not seeing any ICAM clusters as we are seeing in the adhesion sample, although the ICAM1 still remains in the cell junctions. So it seems that the adhesion of the magnetic beads facilitate the formation of ICAM1 clusters. However, the force that is exerted by the attraction of the magnet rearranges the ICAM1 proteins and these clusters disappear. Now, if we are really good detectives, then we must look at different clues together. So we have created composite pictures where you can see the actin-1 layout and the ICAM1 layout together. In these pictures, actin is marked in green and ICAM1 is visible in red. Also, these pictures are the slices that the microscope recorded from the surface of the cells. So you are not seeing the whole cell here, only the top of the sample, the surface of the cells. I have also enlarged one cell from each sample at the bottom. Now, on these samples, you can observe that there are yellow dots. But I just told you that we made actin visible in green and ICAM in red. So how does any yellow get into the picture? Doesn't even have a guess on how does yellow appear here. Well, we have actin marked in green and ICAM1 visible in red. So the yellow dots are the dots where there is actin and ICAM1 simultaneously. So in these points, such as marked with the white arrow, actin and ICAM1 are localizing simultaneously. And we are also looking at the surface of the cell, so I can pretty confidently say that we have found some philopodia, as they are on the surface of the cell and they are co-localized points. So let's observe these yellow dots. Here we are seeing some on the surface of the cell, but if you look at the cell enlarged from the adhesion sample, you will notice much more yellow dots. And then if we move on to the sample of the adhesion plus force, then you will observe again that the philopodia from the surface of the cell disappear. So we are seeing the same pattern in the composite pictures, that the adhesion of the magnetic beads facilitate the formation of philopodia compared to the control sample, but the force that is subjected by the magnet rearranges the proteins of the philopodia, and these formations disappear. So I have told you about one more clue at the beginning that guides us to philopodia. This is myosin 10. So here you can see a composite where myosin 10 is visible in green and ICAM1 is visible in red. This is also a picture that was taken of a sample that was subjected to adhesion. So we added magnetic beads and then we subjected it to force. So we placed the magnet on top of the petri dish. Here, marked with the light blue arrow, you can see a magnetic bead. We will take a closer look at that, but with one trick. You can see these two yellow lines crossing the bead. We've made vertical sections along these two lines. Remember, the microscope is recording the sample in 3D, so we can use software to make vertical sections of this recording, and instead of looking at the horizontal images, we can look at the vertical sections of these recordings. So I've enlarged these vertical sections here, and under the blue arrow, you can see red circular objects. This is the magnetic bead. And what is very interesting is that next to the bead, you can see a green bulge on both enlarged pictures. Now, this green bulge is actually a protrusion on the surface of the cell that is containing myosin 10. So again, we found, I would say that we found philopodia because we know it contains myosin 10 and we know that it protrudes on the surface of the cell. Now, this finding is interesting for two reasons. Firstly, it confirms that philopodia form next to the site of adhesion, which is caused by the magnetic bead. And secondly, it confirms what other studies have observed also, that philopodia usually form asymmetrically, only one side of the site of adhesion. All right, so to summarize these findings, we were interested in learning more of the transmigration process, and for that we chose one of its most mystical characters, the philopodia, and we have used these fake leukocytes to trick the cells into thinking that a transmigration is undergoing, and we also used magnets to exert force on the cells, and then we analyzed our results in the fluorescent microscope. The findings that we learned are that, firstly, adhesion facilitates the formation of philopodia. And this is interesting because it indicates that philopodia is possibly helping the white blood cells in the adhesion step. We also observed that philopodia form asymmetrically. This is interesting because it confirms other studies. And the most interesting is that we also learned that force rearranges philopodia. What this indicates to us is that philopodia, while it possibly is helping the white blood cells in the adhesion step, as it disappears, we think that it is not participating in the actual transmigration, the squeezing through of the white blood cell. So we are hoping that these findings will be starting points for further research that can one day contribute to the development of metastasis-preventing drugs. Now, as we are at a conference about communication, and I have promised you that we will also learn something from these cells, I also have some pieces of advice for you for presenting science. I think that when you are presenting science, you are very much like a white blood cell that is trying to transmigrate through the vessel wall. You are in a high-pressure environment, just like an artery. You are trying to find a grip on your audience, just like the white blood cell needs to stick to the vessel wall, and then you need to craft a message that can penetrate all walls and get to your audience, like the white blood cell needs to squeeze through the vessel wall. And I do think that you have quite a hard job at presenting science, just like the white blood cell has at migrating through the vessel wall. However, and there is two reasons why I think it is actually hard to present science. Firstly, most people will be more interested in everyday topics than in scientific topics. And secondly, what is quite difficult in presenting science is to make your audience understand your scientific message in depth, but you also need to explain it efficiently. However, why I think and why I decided to include some advice on this is because I think that we are a generation that will need to solve many problems, like the climate crisis. And I think that we will need to present science in that challenge, and we will need to make audiences believe in science and understand the science behind solving these global challenges. So this is why I think it is very important for you to be able to present science very efficiently. And I think that there is a huge potential actually in this endeavor, because there are very few scientists that can do this actually very well. So my three pieces of advice are the following. The first one is to include as many visuals in your presentation as you can. As you know, our ancestors started to use their eyesight much, much earlier than we have actually started to use verbal communication. Even worms have eyes, and even worms were able to process visual information. And for this reason, our minds adapted much better to understanding visual information, and our minds are much faster at processing visual information. So you will be able to explain your scientific topics much better with the adequate illustrations. Just imagine if I started explaining the transmigration process with bullet points. I think I would have lost many of you at the second slide. So it is very important to include as many illustrations as you can and as little text as you absolutely need. The second advice I have is to frame your presentation. Our minds have learned to prioritize information based on the perceived importance of information as well. This also have evolutionary roots. The people that were able to prioritize information well had greater chances at survival. So our mind also adapted to prioritizing information based on how important we think it is. So what that tells you is that you need to trick your audience into thinking that the presentation at hand is a very vital, very important issue. So my advice is to start your presentation with framing it as a part of a bigger, very important topic, and then come back to this topic at the end of the presentation. When I first crafted this presentation for a competition, I have decided to include the frame about the metastasis prevention in order to hook the attention of the judges. And it is true that this experiment in the future can contribute to metastasis research, but it is, I would say, it is also not intuitive to include a frame regarding a bigger topic. But I think it places the presentation into a much different view if you include a frame like this, because then you are talking about a solution to a very important problem instead of just talking about an experiment regarding some small micrometer, small things on endothelial cells. So I think it is very important, and it can actually hook the attention of your audience much better. And my last piece of advice is to tell a story in your presentation, as many stories as you can. The seeds of our human civilization actually started around campfires in the Stone Age. And one of the first verbal communication forms that we had was actually storytelling. Our ancestors gathered around campfires and then told stories to each other about their daily struggles, hunting experiences, foraging experiences. And what this caused us, again, is that our minds adapted to listening to stories. Here, again, those who were good at listening to stories had greater chances of survival, because you could learn from other people's experiences, and then you were much more prepared for daily life. So our human species has been listening to stories for many thousands of years, and we have adapted to listening to stories. So what I suggest is that you make your scientific experiment a part of a story. You frame your whole presentation as a plot. Now, how do you do this? Because it can seem difficult with scientific topics. I would say that you, as researchers, are actually very strong archetypes from different stories. Researchers, I think, are detectives. Researchers are explorers. Researchers are revolutionaries. You just need to make use of these archetypes. You need to present as if you were a detective solving a crime, or as if you were an explorer exploring something new and very interesting, or as if you were a revolutionary presenting something that will change the world. And if you use these archetypes and then you craft a plot for your presentation as if it is a detective story, then you have a very good and very compelling scientific message. So these are my 3 pieces of advice. I hope they will be helpful to you. And with that, I thank you very much for your attention, and I am open to all questions. Thank you.
Thank you, Balázs. I must say 3 little words or 3 little piece of advice, or not advice, piece of issues. At first, I have to say a big, big thank you for your presentation, for your marvelous presentation. The second one, I want to ask you to write into my memorial book, and I need to congratulate for your wow. So, as I know, you are the 6th for the Hungarian biological competition on biology. The third one, sorry. So I have to congratulate.
Okay, so next up is our second invited lecturer today, Ms. Petra Hargitai, the student council leader of Ötvös József Secondary School, the Secretary General of BIMUN 2024, and the ambassador of Association of Hungarian Women in Science. In her presentation, she will be giving us all her tips and tricks on how to enhance our speaking credibility.
Thank you. Good morning, everyone. First, I would like to ask, who drank coffee this morning? Who drank tea? I also drank a tea. And who drank an energy drink? No one. You guys are well. Wait, one. one person. I just wanted to say that everyone is so healthy, but I'm going to stick with that. So, hi, my name is Petra Hargitai. As it was mentioned before, I was the student council leader of the organizer school. I also do a lot of public speaking regarding being the Secretary General of an MUN conference, and I'm also the ambassador of the Hungarian Association of Women in Science. I would like to share more practical tips with you than detailed scientific research as Balázs did, but it has a really good connection to what he has mentioned before. So recently I have taken part in a scientific competition at the University of Szeged, where we had to hold a 3-minute pitch about the topic we've chosen and the solution that we wanted to propose. What I realized there that many people just didn't know how to speak. They went out, had amazing ideas, amazing solutions to very big problems, yet they couldn't give the message to the judges, and they couldn't share the message with the audience. And this is what I want to change here today. The technology. So I would like to show you the steps of preparing a presentation, or you can also use this when you're writing an essay. I will go into the details of most of these points, except for choosing a topic, because sometimes it's given by the school, or sometimes if you're preparing a scientific presentation, it's connected to the research you've been doing. So firstly, the research. This is, I'm referring to research as trying to find information on the internet rather than what Balázs did, went to a scientific lab and did some experiments. I would suggest you get a great overview of the topic. You can read Wikipedia or the book that you have at home. It is always great to start somewhere that has general information that is not so in-depth, so you can understand the whole point. It is important to speak with, for example, teachers. When I did my presentation in Szeged, I talked to my biology teacher regarding what he would suggest that I tell about hormonal health, because that was the topic I was presenting there. When you're trying to do your research, I suggest you collect all the information in a Word, Google Sheet, or an Excel. I have recently been to a presentation by Karikó Katalin, the Hungarian Nobel Prize winner that has most recently been selected. And she told us that when she's doing a research, she has a topic regarding messenger RNAs. She's always collecting it in an Excel, pasting the link where she found it, write the date of the article, and write some key information regarding that. When she's trying to go back and use it next time, then she knows where to find it. It is also important to get the definitions that you're going to use. Just like Balázs did, he had some very biology-related words that many of you might not have known, but it is great that he has explained it, and so now you know what it means, and you have been able to follow his presentation due to this factor. Then, when you start to organize, you have done your research, watched 20 videos online, read hundreds of articles, and talked to many people. Then you have to collect what you have read. When you're writing, for example, a speech for a debate competition, it's important to collect pro and contra arguments. But when you're doing a scientific research, it's a bit more complex. This is why I would suggest creating a mind map. As childish as it might sound, I don't know, I've done it last time in 5th grade until I started doing these presentations. It's always important to have the connections between the topics, and then you know which is the key and which should be the starting point. When you're writing your draft, it's always important to introduce yourself, tell why you're here at the event, just like Balázs and I did. When you're writing an introduction, you don't have to go into personal details, just give your name, your background, and yeah. When you're as Balázs stated, it's important to give a whole picture of the topic that you're going to speak about. You have to be able to give the full picture and then go and, just like a microscope, just go into the small details moving on. If you're after this is when you state your hypothesis or your statement and just explain your point of view and how you are involved in this topic. When you are writing an argumentative speech, it's important to have rebuttals, and also there might be also in science some questions that, for example, the audience might ask. It's also important to have prepared answers for these. When you're going to summarize, get to a conclusion, Balázs is really a perfect example for everything I'm saying here today. He had a great summary, told you why he was doing the research, and also gave some personal message, which is, I think, an amazing thing to give some personal piece of yourself to the audience. It's going to make you more likable and more memorable, especially if you're taking part in a competition. So, preparing a presentation, it's important that you don't have a lot of text on it. You don't need a whole textbook written out in a PPT. You have to use a lot of visuals, images, and try to stay away from using hundreds of statistics, because at the end of the day, nobody will remember the percentage or the specific number. It's always a great thing to get some connection with the audience. Just like I did, I asked you if you have drank coffee, if you have looked around, most of you have. So it's always great to have some starting point connections. It will make you more favored, and it will be a little more personal. This is what I'm trying to highlight throughout my little presentation. I have recently, just as mentioned, been in a competition where we weren't allowed to use presentations due to the technical difficulties. And this is when they suggested us that we use a one-pager. I don't know if you have heard this term, a one-pager. I don't think so. So I think this is especially good if you're going to a competition. Prepare a little A4 or A5 document that you're able to hand out. If you hand out this paper to the judge when you're starting your presentation, and at the end of listening to all of these, they will have something to remind them of your presentation. When the 10 judges or 5 judges will go privately and talk about who the winners should be, they will have something that you gave them that will make you a little more special than everyone else before you and after. It worked very well with us. We had handed out some papers to the judge, and at the end it was maybe the deciding point on who should be the first. If you're preparing a Kahoot or some games, make sure to check the technology beforehand and don't be late. I was late today, so I had to use Balázs' laptop, but be more prepared than me and have your PPT on a pen drive, or just don't always rely on technology, because something, especially when you're going somewhere that you haven't been before, giving out a presentation, it can really be challenging to figure these out. And what I've mentioned before, don't use too many statistics, but when you're using them, state the source under the image or the statistics, because it makes it more credible. For example, if you're mentioning a research, I would always suggest stating the year. For example, a Harvard research in 2016 has concluded that, and it will make you sound a lot more involved in the topic than just saying a research was done. Learn and practice. I don't think that I have to go very into details about this. It's something that most of you will be doing if you're trying to give a presentation. It's a lot easier if you don't have the whole text printed out, because you will get lost within the lines, because when you're in a high pressure situation, you will forget and you will change up words. And if you print out the whole speech, I have seen this many, many times at MUN conferences, and I can see some familiar faces who are also been doing MUN, for example, Balázs. This is something that happens, and it's very stressing when you're standing in front of 400 people and getting lost in your own lines, in the speech that you have written. So use a cheat sheet. Now I'm using my phone, but normally I wouldn't recommend it. I just didn't have time to print it because I couldn't get the metro. But I would, when you're, especially in competitions, I would suggest getting an A5 sheet that you print and put your name or logo or slogan on the back. So that is what the audience is seeing. And keep in mind that sometimes you will use a microphone, just like now, and then you won't be able to, for example, flip pages, because then the microphone will not have the voice as it should. So I would suggest thinking through all the circumstances, whether you're speaking in a big auditorium with hundreds of people or just giving a small classroom presentation. It's also very important to know when you're going to go to the next slides. I always have these very harsh lines on my paper when I know that I will have to turn a slide or turn a page, basically. And so you know when you have to get onto the next subtopic. And moving on. Yeah, this is basically, and one last thing that I've told you that I will be talking about how to be credible. I would always highlight that be confident. You don't actually have to be, you just have to show that you're confident. It's sometimes easier if you're just trying to pretend than actually being. It's also important that you are enthusiastic about the topic you're presenting. When Balázs was talking about his vessels, his eyes were sparkling all the time. It makes it a bit more special and a bit extra, and always know more about your topic than what you're presenting. Now, what I've experienced taking part in several competitions and conferences, that you have hours and hours to prepare, but you only have 2 or 3 minutes to give an abstract on what you are going to be, what you have researched, what you're going to plan, and it's very hard to find the key points in only 3 or 2 minutes without needing to go into very depth. It's always important to dress appropriately. I don't really have to emphasize that, but it's always better to be a little more dressed up than dressed down. And be prepared for questions. I have a personal tip for you. When I'm trying to give a presentation, and I always go to my mom and I always present her my little slides and what I'm going to say, and I always ask her, or if not her, some of my friends, that, okay, now at the end, what do you think? Ask me questions. What were some things that I didn't specify very clearly? What were the things that you would want to hear more about? And what were the things that you think that I shouldn't really explain so deeply? And they always give me some very great questions and some things that I have to prepare for, because everyone can always ask something new. So I would suggest interpreting the questions into your presentation, or just being prepared and having a little cheat sheet that you have some answers to the yet not told questions. So this is my final line, that you should be confident and you should love what you're talking about, because it always makes it a lot more open for the audience. It's always important to connect with those who are in front of you. Even if there are hundreds of strangers in the same room, there is always something bringing them together for that specific event or for that specific class, or basically anything. Just try to find these connections, and it will make your presentation a lot more personal and a lot more adaptable if you have these points. And thank you for your attention.
Okay, now we will have a short Q&A session. We will start with a question from yesterday, and it's a question to the Russian presentation, so I will read also the answer. We have the question from Shivanyali Sapra, India. In some cultures and places around the world, the meanings of certain emojis can be different. Also, sometimes common emojis having few different, though similar meanings are misinterpreted. What can be done in order to use emojis for general communication in such case? And the answer, it is very important to use emojis effectively in your general communication while minimizing the risk of misinterpretation. Among the other considerations, there can be as follows. Firstly, we should use emojis mindfully with respect to the cultural context and sensitivity of those whom you are communicating. Secondly, it's important to mind the context. We should make sure that the chosen emoji aligns with the message we are trying to convey. Thirdly, we would recommend to avoid overusing emojis to prevent from cluttering your message and dilute the intended meaning. And more important factor may be clarifying when necessary. If there is a potential for misinterpretation, consider providing additional context or clarification to ensure your message is understood correctly. And they hope that fully covers the question. Yeah. Okay, now we have the next question from Belgium to the caffeine presentation. Oh, okay, then we can jump on that. Yeah. Oh, okay, and you can ask questions for today's presentations as well, because yeah, you can ask questions. Yes.
I got a question for the cricket presentation. What did you do with the crickets afterwards?
Oh, that's a great question. Well, we have like domestical crickets, and they don't live long, and we buy well, they are sold for food, but we didn't eat them. So we just carried them until they die for like natural death, because they don't live long, and we buy them really as old as possible, so they just peacefully died.
Thank you. Yes.
So also for you, in your last experiment, you did the experiment 4 times. Was it with the same crickets, the same female, or was it with each time a different female? Because you show that you have 2 same results, so that the female can reach the chi, that's the word. 2 times they can reach it, and 2 times they cannot. And my question was it the same female, and you did it 4 times with the same female, or was it with each time a different female?
It was with different females, but the female we use on there's 2 female on the trials. like test the control trials, and the deaf female wasn't on. Well, we just do the control trial with her with sound because, well, she's deaf anyway. So, but we use again the female we used for the control trials, and I think she's one of the one who which actually reach the sound. So. But the other time we used different females because we had a lot of females, so that was the occasion to try with different specimens.
Yeah. Okay, so we have these questions from Noah Kropp, Germany, to the well communications presentation. Is it possible to recreate the sounds of whales so that humans could use it to communicate underwater, for example, with U-boats or during diving? And, yeah.
So actually, it's possible. In fact, there is in Korea, I saw it on internet, there is in Korea a project for submarines for military communication. So the goal is to communicate but secretly, you know. So they managed to do something really, it sounds really like the whale sounds. So actually it's possible, but it sounds like, actually it's not like there. So to create it, for the moment it's a bit complicated, but there is a way to do it. Actually the whale doesn't answer to tools, but we have a way to make it sound like. So I hope one day scientists and Korea military will maybe work together, but I mean, military secret, it could be difficult. So yeah.
So I have a question, like following your answer. So that use could that use like disturbing the whales because like it's a perturbation. So do you think it would be a problem? Or?
So actually, as we said in the ethically point, is it allowed? You have a very good question because actually, yeah, it disturbs animals, it disturbs whales. So we hope anyone will use it this way. We hope we will do it well. That's the point. Because of course, it disturbs if we sometimes, for example, say there is food this way, and we don't know what we are saying, and for example, they'll go this way, and there isn't, they'll die, and I don't know, something. But that could be a problem. So yeah, we could disturb them, of course.
Okay, another question to the synthetic muscles presentation. In what ways can the muscles be used in space?
So the muscles can be used like in space because, as Lena told you, they are very lightweight and easy to move. Because, as you saw, this muscle was like really small and light. So, because in space, it is better when things are light and not like very heavy. So. It is possible to use synthetic muscles in space maybe in the future because they are very lightweight.
Okay, the next one is a question on communication between human and whales. For any AI to function well, we require humans to put in base data. This means that to analyze whale sounds effectively using AI, we need a human analogy first, which takes years. Is there a better way to communicate with whales than AI till it's efficient enough not to misinterpret signs? Yeah.
Okay, so it's quite a big question. Is there a better way to communicate with whales than AI till it is efficient and not misinterpret signs? I would like to say that actually I don't really know if there is a better way. For me, it's one of the best way to do it because it's the more efficient for me, I guess. There is maybe another way to do it, but I think that using technology in our era, it's maybe the best point because it's one of the most efficient tool we have. So for me, it's the most efficient, but of course it depends on the point of view of the people. I guess scientists have some more efficient way to do it. Maybe in a few years they will be able to create a new tool, maybe more efficient, maybe they will discover something new. But actually for me the most efficient is the AI. It's one of the most powerful tools we have. It's one of the most developed tool we have, so for me it is. I don't know, so who was it? I guess it's a girl or a guy, I don't know, from India. If you had a better idea, so you ask the question, maybe you have another way to see it, but for me it's the AI.
Okay. So unfortunately, this was our last question, so we won't have time for this one today because you will go and explore the Buddha Hills. So please pack your stuff and grab a sandwich outside, and yeah, that's it.
And we would like to ask the people from Hungary and from India to go back, and the others stay here when you've already got your sandwiches and stuff.
Rika,